Welcome you all, my dear students. In this video, we will be studying a shear force diagram and bending moment diagram. How to draw this one? Okay. This video will be of three parts. The first part I will be discussing basics of shear force and bending moment. And second part I will discuss all the problems, that is shear for drawing a shear force and bending moment diagram for cantilever beams cantilever beams. And in the third one I will discuss about third video I will discuss about all the beams, simply supported beams I will consider. And for those simply supported beams, how to draw shear force and bending moment. Here in this fourth video I will consider only for basic beams, that is fun, easy and simple beams, or you can say standard beams. Standard beams These standard beams will be asked for just a small this one in your examination. It might be 2 marks or 3 marks question. And after that I will cover in the fourth video simply supported beam for with the various combinations of loads. For all the combinations of loads that I will consider, this will be a very big video. And first in this video, this is called as a part 1 video. I will cover basics of shear force and bending moment. Now in this video we will be discussing definition and basic definitions and definitions of bending moment, definition of shear force, and rules to draw shear force and bending moment diagram, features of shear force and bending moment diagrams. Okay, salient features. First one, definition. You should know the difference between the force and shear force. Then only you can enter into shear force. First, you should know what is force. Force is an external agent. No, this is an external agent applied to the body, which tends to change the state of body. See here, I have got one box here, and this person is pushing that box. Means this person is an external agent that is applied to the body to change the state of the body. Now it is in rest and it might be moving, or it might be moving and he is making it to rest. Okay, that is the force. Force means it might be a point load. It will be a point load, that how he is applying. It will be having some four characteristics that are already discussed in engineering mechanics first chapter. This force will have point of application, direction, magnitude, and line of action. These four characteristics it will have. That is called the force. For sign conventions, how we use in support reactions for force: rightward going positive and leftward going negative, upward going forces are positive and downward going forces are negative. These are the sign conventions used for forces. Now we are entering into something a different force or a special kind of force, that is a shear force. Shear force, shear means what? Shear means a tear, you know, turning, tear off, that is a tearing, or otherwise that is a collapsing, that is collapsing, that is called as a shear. Just I will show you one diagram so that you will understand what is the difference between the shear force and the normal force. Let us consider this is a box, and here I am applying one force here, the another force I will apply here. Now you can see this force line of action is passing through the other force, means this is towards, that is ending towards this one, and this is ending towards this one. Therefore here whatever that the effect is there, no, this is called the compression effect. This is a compression. Okay, because both are normal to the surface, that is a perpendicular to the surface, and both are access to the one, both are having one line of action. This is a compression. Now I will create uh, one body here. Let us consider let us consider this body, and this is a line of action. This is a line of action. Now this time what I do, I will apply one force just above the line of action and one force just below the line of action. Okay, of course they are acting with the line of action, but you can see here a fraction, a small nano or otherwise micro level small distance is there between this force and this force. That's why this box, how it will behave. Now in this case this box will tear off. No, this box will be like this because the upper part of the force is pushing the upper part of the body. This force is pushing upper part of the body, and this force is pushing lower part of the body. Understood? That's why this is called as a shearing. This is called as a shearing effect. Understood? Now we can see this one. Shearing force are unaligned forces pushing one part of the body in specific direction and the other part of the body in opposite direction. That is called the shear force. Okay. Whenever I say I force, then force means just one arrow mark that side or this side. This is just a one arrow mark. When I want to explain this shear force, then I have to take two arrow marks, one like this and one like this, or otherwise one like this and one like this. Two arrow marks together, they will show the meaning of shear force. Understood? Now, moment I have to understand first, and after that I will go to the special form of moment is a bending moment. How we discuss that force and shear force the same way. First, I have to understand what is the moment. This experience you might be having that one a nut is there here, and you are having some lever arm, and through this one you will apply some perpendicular forces. You will hold this one this way, your hand will be like this and you will pull it, or otherwise you will push it. you know. How you are pushing, you are making this one with 90-degree with this arm, and that's why you are generating one moment at this particular point. That moment, if you are pulling it down, then that moment is called as clockwise movement. This is clockwise, like a clock. Then if you are pushing it, it might be anti-clockwise movement. Now see, the moment is what? That is the force into perpendicular distance, that is considered as a moment. Right? Now force into perpendicular distance. Now how you recognize the moment? The moment directions will be either it is clockwise, considered as a positive, and it is a negative, that anti-clockwise considered as a negative. This is a definition of moment. It's just a moment. Right? Next, what is bending moment? Bending moment is nothing but a special form of moment which bends the beam. Here you can see this arm is not bending because it is just rotating the nut. This arm is rotating the nut. It is not bending the arm. But bending moment means what? Here two moments are acting which are equal in magnitude and opposite in direction, and these are bending the beam. This axis is bending. That's why bending moment is the moment which is responsible for bending of the structure or a beam. Understood? Now, this is called as bending moment. You should know the clarity between the moment and bending moment. Whenever I show moment, I have to use one clockwise or anti-clockwise rotating arrow. And here, when I want to show the bending moment, I have to show two moments like this. Or otherwise, I can show the two moments in this way. Okay. Then this sign conventions we'll see later. Right? You should know the difference between bending moment and moment, like force and shear force. The same way you got the difference. Now shear force, you have experienced this one in your practical life. That is, the scissors are always parallel sliding steel plates, right? This is the steel vein, and one vein is here and another vein is here, and these two are sliding each other with a small gap. When you provide a small gap and these are sliding, then you will see the paper is subjected to one force this way and another force this way. Then you can see the paper will tear off. No, this is called as a shear. That is called as a shear. When you see this shear, then you should use the sign conventions. Say for example, this is the distance, that is a section where you want to cut the paper, then this is the force you are applying in one side, and this is a one scissor, and your force applying in another scissor. Then this is called as a sign actual effect in the scissor. It's not like this, you don't have any distances. This is wrong. This arrow marks what we have shown with a big distance here, that is wrong. Just for convenience, you have to remember that one force and another force acting, right? Then this is called as a shear. Okay. This is a practical way, but free body diagram for this scissor action is this one. The free body diagram for scissor action is this one upward and one downward. Okay, Now, what is the definition of this shear force for a particular section? What we studied in previous slides, that is a common definition for shear force. But if you want to determine what is shear force at this point, at this section, then you have to remember this algebraic sum of all the transfer forces acting on the beam, either left side or right side of the section. Okay, remember in this way, here we have to understand each and every word, that words here. Algebraic sum algebraic sum of all the transfer forces means you will be having axis of your beam or otherwise paper, whatever it is. The axis is like this, and these forces are perpendicular to the axis. Those forces are perpendicular to the axis, therefore they are called as a transfers. If you are using a horizontal beam, if you are using a horizontal beam, then you can replace this word by vertical. Then your definition will be algebraic sum of all the vertical forces acting on the beam, acting on the horizontal beam. Okay, now algebraic sum means what? Algebraic sum means, this word is very important, you are not just summing up all the forces. Algebraic sum means you have to consider sign conventions. There are sign conventions that I will explain in the next slide. That sign conventions you have to consider, some forces are plus and some forces are minus. In that way you have to add them. Then what you have to add? You have to add all vertical forces. Vertical forces where? You have to consider right side, either right side or left side you have to consider. Okay, this is either, this is the right side and this is the left side. You have to consider either right side or left side. This word is very important. Or means choice is yours, whether you would like to see in the right side or you would like to see in the left side. Because before tearing of any paper or otherwise beam, that section is considered as equilibrium. Equilibrium means this force and this force are same, equal. That's why it is your choice whether you see left side or right side of the section. Okay, that is very important. Once again, you can see the definition. Algebraic sum means there are some plus forces, minus forces, those you have to add, and all the vertical forces acting on the beam, you have to consider either left side or right side of the section. Okay, that is your shear force. Similarly, we have to study this bending moment. When you are applying some moment here, if you fix this point, what happens? If you weld this one, what happens? Then when you apply the force, this arm try to bend, or otherwise it will resist the bending. It will try to bend or it will resist the bending. Then this effect is called as a bending moment. Okay, you will be having this experience. You will take a stick, ice cream stick or otherwise any big stick, then you will apply some force here this way, and you are applying another force this way. That's why this arm, this stick is bent. This is called as a hogging bending. This is hogging. The stick is like this. If the stick is bent like this by applying one force here and another force here, this is called as a sagging bending. That is called as sagging bending. Understood? Now you can see what we did for that stick. We applied one moment here in this direction, another moment here in this direction. Therefore, the stick was hogging effect. It was producing hogging effect. This hogging effect is called as negative bending moment. We will call it as a negative. Okay, na? Then what is a positive? Positive will be sagging. The positive will be sagging. Right. Definition. Here what we are doing is algebraic sum of all the moments. Algebraic sum of means moments. These moments either they might be plus or minus. Plus means here the moments may produce a sagging effect. If they are producing sagging effect, that is a plus. If they are producing hogging effect, that is a minus. Then the algebraic sum of all the moments acting. Here also you have to consider two sections. That is, this is a section, this is a section. You have to consider either right side or left side of the section. That is your choice. Okay. Once again, algebraic sum of all the moments acting either right side or left side of the section. Right up. Next, Here we got a meaning this algebraic sum. I have explained you algebraic sum means some sign conventions you have to use. For shear force we have sign conventions like this. Then if this is your section, if you are observing, very important, if you are observing right side, then downward forces are positive. If you are observing left side, then upward forces are positive. Both are positive. Okay, this is like this effect is called as a positive. That's why where you are observing, if you are observing this side, then all downward forces are positive. All downward forces are positive. Once again, then if your observation is towards left side, then all upward forces are positive. Positive again. Okay, for that you have a hint here. I used to tell like this: look, or otherwise run. Run means right up negative. See here, right side upward is a negative. That's why it is a run. That is right up negative. What about right down? Right down is a positive. Like that. Look means left up a positive. Left side upward forces are considered positive, and left side downward forces are obviously negative. That other sign conventions you can see it like this. This is a negative sign convention. Same figure is there here, but you can see the observation when you are making it left side, then all downward forces are considered as negative. Then when you are making observation on right side, then all upward forces are making, sorry, all upward forces are making negative. Okay, these two effects are negative effects. These two are called as positive effects. This is sign convention for shear force. The same way, sign conventions for bending moment, it is like this is your section, and if you are observing towards this side, see, observing toward this side means you are making it fixed. And see here, this is called as sagging effect. This is sagging effect. The same effect even you will see when you observe in the left side also. This is also sagging effect. Therefore, this is called as a positive bending moment. This is positive bending moment. Okay, and see here, observation is right side. This time this is making hogging effect, and left side also it is making hogging effect. Therefore, this is negative sign. Understood? Okay, here be careful. Many students make mistake while considering the sign conventions for bending moment. That mistake is they pronounce clockwise and anti-clockwise moment. No, do not pronounce clockwise or anti-clockwise when you are dealing bending moment. When you are dealing bending moment, do not use clockwise or anti-clockwise words. Okay, you say sagging or hogging. Okay, sagging moment or hogging moment, that you have to see. That I will explain you when once I solve some problems. Okay, you can see sagging effect means this is a smiling effect, therefore it is positive, and hogging effect means it is a crying, this one, therefore it is negative. You know, the bodybuilders, they show their body, either it might be a sagging, means the arms are upward, and they may show their body with the hogging also. Okay, you can consider this as your section. Right side your hands is going upward, therefore that is a positive. Left side also your hands are going upward, that is your positive. If this is your section, and if your left side hands are coming down, and right side also hands are coming down, this is a negative effect, and this is a positive effect. Okay, these are all sign conventions for bending moment and shear force. Now, in that definition I have told you either right side or left side of the section, right? Once again I'll write here, either either right side or left side of the section. Left side of the section, right? Of the section. Here we we know that we have a choice here, where you want to see left side or right side. R is there, no, therefore it is your choice. You see left side or right side, that is your choice. Therefore I don't comment anything on this one. But be careful, this section you have to choose. Section you have to choose, and after choosing section you have a freedom to look either right side or left side. that freedom is there, but how to select the section? Okay, after taking the section you have a freedom of looking at right side or left side, you know? But how exactly or where exactly you have to choose the section? The first rule to choose the section is wherever you require there you take. Say for example one beam is there like this, and UDL is there, and point loads are there, and these some points are there here. You can call this as a point, B point, C point, D point, E point, like that, right? Then where you want shear force, wherever you want. You may require shear force here, shear force here, shear force here, shear force, like that, right? It doesn't mean first section where you want means wherever you need there you have to take. But there is one rule, there is one standard rule, that is shear force. When you are dealing with the shear force, then at that time if you are encountered the concentrated load, let us consider there is a beam here, and this simply supported beam, and there is a point load here. It might be one point load here. Where this point load is acting? At this point, is at this point the point load is acting. Now at this point, according to theory, the shear force is discontinuous. Later I will explain you why, what is the meaning of discontinuous. Okay, now see, at this point where point load is acting, the shear force is discontinuous. Therefore, if you want to know shear force, then you have to take two sections. One just left of the point load and another just right of the point load. Okay, now one just and one right, one just left and one just right of the point load you have to select. Then you have to study that shear force diagram. This is a rule. You have to follow it. What is the rule? When you are dealing with shear force, you just remember like this. Okay, when you are dealing with the shear force, whenever you encounter a point load, then take two sections, one just left of the point load and another just right of the point load. Okay, how exactly we have to consider that I will explain you when I deal a problem, right? Now coming to the next one. Next rule is when you are dealing with a bending moment, when you are dealing with a bending moment, at that time, wherever moment is there, see at this point, moment is acting now. Then, wherever the moment is acting, there you have to take two sections. Two sections, one left of the moment and another one right of the moment. Why? Because at that point, bending moment is discontinuous. The meaning of discontinuity that I will explain later. Don't worry. You just remember one rule. This is a rule. When you are dealing with the bending moment, when you encounter the point moment on a beam, then you take two section, one left of the moment and another right of the moment. This much you remember. Right up. Now, one standard procedure I will tell you, some standard steps I will be listing here. Those procedures you have to adopt when you are dealing with the shear force diagram and the bending moment diagram. Shear force diagram and bending moment diagram. Right? The first and very important that step is draw free body diagram. Free body diagram you have to learn. This in engineering mechanics you are very familiar, but here you should know some backup to draw this shear force and bending moment diagram. That backup is you should know how many supports are there and how many reactions for each support, that you should know. Here usually we will be using three type of support. One is the roller support. You know that roller support will have one reaction that is perpendicular to the surface, and you have a hinge support. This is the hinge support, and there you will have a two reactions, one perpendicular to the surface and another parallel to the surface. Okay, now this is a hinge support, and you have another support, that is your fixed support. In this fixed support you have a three reactions, one is parallel to the surface, another one is perpendicular to the surface. You will have moment also here. That's why remember, roller support one reaction, hinge support two reaction, and fixed support you have a three reactions. This much of basic knowledge you should know to draw free body diagram for a particular beam. Then after that you should know the support reaction, how to find the support reaction. A previous chapter or in engineering mechanics you should know that how to find exactly the support reaction. Okay, you should know the equilibrium conditions for that. Equilibrium conditions, summation of moment at A equal to 0, then you will find one equation. there you will find RB equal to some value. You will get RB value. Then after that you will substitute summation of Fy equal to 0. Then after that you will solve for Ra. Like that you will find the reaction at A point and reaction at B point, one support and other support. And even if any inclined forces are there, sorry, inclined force or horizontal forces are there, then effects also you can deal, and that you will come. Get it? Right on. This is a determination of support reaction. Be careful and correctly you determine support reactions. If this support reactions goes wrong, then the entire SFD and BMD that problem will be going wrong. Okay, now. Next, the third one is very important. The using definition of shear force and bending moment at any section determine shear force and bending moment at all the points wherever it is necessary. The sections I already told, and definition is also known. Definition is what? Algebraic sum of all the moment, all the vertical forces, either left side or right side of the section is shear force. Then what is bending moment? Bending moment is the algebraic sum of all the moments, either left side or right side of the section. Okay. Then here you should know to draw this shear force diagram and bending moment diagram, the backup required is variation of shear force and bending moment between 2 points. Let us consider this is a beam. This beam with the various forces, one UDL and one point load and moment is there and UVL is there. Like that, this beam is with the many type of forces. Then you should know how the shear force is varying between these 2 points where UDL is acting. How the shear force will vary between 2 points where no load is acting. How you should know the shear force acting between no load is acting. How shear force variation is there when UVL is acting. The same way you should know the variation at this point, this point, this point, this span, where you bending moment variation also. Understood? That I'll explain in the next slide. You can see a type of load and shear force and bending moment. Pure bending is a type of load. Pure bending means you have one beam and you are applying one moment here and another moment here. Now see, this is one point and this other point. Between these 2 points, you will not find any shear. Will not find any shear. Then variation. This is a bending moment variation is constant, or you can say rectangular. Rectangular. Okay, means let us consider there is a beam like this and you are applying some force moments like this, then shear force is 0 and bending moment diagram will be something rectangle. This is a bending moment diagram and this is the shear force diagram, right? Then look at here, when between 2 point loads, let us consider this is a beam and this is one point load and this is another point load. Between these 2 point loads there is nothing, you know. In this case shear force diagram is constant. Shear force diagram is constant means it is a rectangle. It is a rectangle. Then bending moment diagram is linear variation. Between these 2 points bending moment diagram will be linear variation. You can call it a triangle. Triangular variation. Okay, 0 and rectangle, rectangle, triangle. Then this is the triangle to parabola, parabola. Then this is parabola to this is a cubic variation, like that. Whenever there is a pure bending, this is and this is a pure bending. 0 rectangle, point load and this is a point load. Between 2 points no load, constant, that is rectangle and triangle, these two variations. Then like that when you have a UDL, then this is one point and this is another point. Between UDL, triangular variation and parabolic variation. Between UVL, this is your UEL, no, then this is one point, this is another point. Between UVL, then shear force is parabolic variation and bending moment is cubic variation, right? The exact meaning I will teach you when I consider problems, right? This is enough. This much is there in this part 1, and in the next video we will be studying how to draw shear force and bending moment diagram for cantilever beams. Thank you very much.